Hello, welcome to part 5 of revising for the specialist exam. Now I've travelled all around the country, I've read all of the past papers from the other states, and I'm going to show you some questions that wouldn't look out of place on a Queensland specialist exam. Okay, tech-free multiple choice from New South Wales last year, give yourself 90 seconds. Alright, I'm going to solve it in 3, 2, 1, let's do it. So just by looking at the question and then looking at the solutions, it's clear that we're looking at an integration by parts situation. So here's my formula sheet. You can work with whichever one you like. I like this one right here, so I'm going to use that. So the question is, which one should I make U and which one should I make V? If you've watched my previous video on this, you'll know that I use this acronym here, detail. That means that dv dx should be either an exponential function, or if you can't find that, it should be a trig function or an algebraic function or an inverse trig function or a log function. I've got an exponential function, which means that dv dx should be that one right there. So writing this all out now, I've got dv dx is equal to e to the 7x, and u is obviously equal to that, x to the 5, and u dash, or the derivative of u with respect to x, is equal to 5x to the 4, and that leaves v where we integrate that. And that's going to be 1/7 e to the 7x. Okay, so now that I've got all of this information, I'm just putting it into this formula. So u dv dx is equal to uv, let's write that, uv, and then minus the integral of v, 1/7 e to the 7x, times du dx. And du dx is 5x to the 4. Alright, so one of these is going to be my answer. We've got x to the 5, so x to the 5, x to the 5, so it's either this one or this one here. We've got 1/7 x to the 5 e to the 7x minus, and then it's got this 5/7, 5/7. So we can see that 5 and the 7 comes out, so that makes sense. Minus 5/7 integral e to the 7x, x to the 4. Okay, looks like I need this one here because I need that x to the 4. My answer is A. Probably worth taking a moment to reflect on how much working out you should do on a question like this, right? I've probably simultaneously done too much here and also not enough. If this was a short response question, I've obviously got to tidy this up because I'm scribbling bits and pieces all over the place. But if it's a multiple choice question and you can kind of start to intuit what these answers are going to be straight away. So if you're thinking about it, you go, oh, it's definitely going to be x to the 5 and x to the 4. You can get A much faster than I got A with much less working, I think. Have a think about it. Next question. Alright, so still tech-free. We're in Victoria in 2009. Give yourself 90 seconds. I reckon you're going to have to motor to get this done. Alright, I'm going to solve it in 3, 2, 1. Let's go. Alright, I can see they're looking for momentum, right? So I know momentum, P equals mass times V. Now I can see I've got a mass of 5, so P equals 5 times the velocity. If I knew the velocity, that would be great. Now it says its speed, the mass increases its speed by accelerating in a straight line at a constant rate. Alright, so acceleration with respect to time is equal to that constant rate. Now that means that velocity with respect to time is equal to the integral of that, which is 2t plus c. Now I'm told that it has an initial velocity of 4. So at t equals 0, v equals 0. And if we were to sub 0 in here, v equals 4. And if we were to sub 0 in here and 4 in here, we would find that c is equal to 4 as well. So we have a velocity function, 2t plus 4. Now it says we want to know the momentum when its displacement is 21. So we need a displacement function. X with respect to t equals t squared plus 4t plus another c value. Now, at time 0, its displacement is 0, so its c value is 0. So x with respect to t equals t squared plus 4t. Okay, I think I'm done there now because we want to know after traveling 21 meters. All right, so distance 21 meters equals t squared plus for t. And we need to solve that. All right. Don't have a calculator, so I'm going to have to go old school here. 0, that should be a 21 there. Factorising this monic quadratic shouldn't be too hard for you. You've got t here, you've got t here. Feels like a 7 and a 3. And I'm going to need, like, which one of these needs to be negative? Probably this one, right? Okay, that checks out. So t can be equal to 7 or, t can be equal to -7 or +3. But this is time, right? So we need to reject that negative solution. Therefore, t is equal to 3. All right, I think I'm nearly there. Nearly. I know that the time is equal to 3. If I sub t equals 3 in for my velocity function, v3, I get 2 times 3 plus 4, which is equal to 6 plus 4, which is 10. If I sub 10 into here, p equals 5 times 10, I get 50. All right, and my answer there is D. All right, so this comes from the Victorian paper, one of the last multiple choice questions, so it's obviously one of the harder ones. It takes a while, 90 seconds, maybe 2 minutes, but as soon as you see momentum, you're writing this down and you're figuring it out. I think it's a fair question. I think we could see something like that. All right, it's time to move away from these multiple choice questions and move on to some short response questions. Here we go. This one's from WA in 2020. Have a try, see how you go. 5 marks, so give yourself about 7.5 minutes. All right, I'm going to solve it in 3, 2, 1, let's go. Okay, so we're doing a definite integral with a u substitution. So we're going to need to change these terminals so that we can work directly with this u value once we've integrated it in terms of u. So when x equals -1, u equals, and we just sub -1 into there, right? U equals -1 plus 2, the square root of that, which is the square root of 1, which is 1. All right, so when x equals -1, u equals 1. And we can do the other bit here for this 7. When x equals 7, u equals the square root of 7 plus 2, u equals the square root of 9, which is 3. If you're looking at your screen and screaming like plus or minus 3 or plus or minus 1, that's wrong. That's not it. If u is equal to the square root of x plus 2, this is explicitly positive. If they didn't want it to be explicitly positive, we'd have a plus minus out the front. We don't. So the square root of 9 is 3. It's not plus or minus 3. It's only when it's the result of solving an equation and having a square root appear in that you need that plus or minus. Hope that makes sense. Still got some work to do here, because if we're going to do a u substitution, we know that u is equal to, I'm going to write it as x plus 2 to the half. Same as the square root of x plus 2, right? The reason I'm writing it like that is because now I need to find the derivative of that if it's going to be useful in my u substitution. So the derivative of that is going to be equal to x plus 2 and decrease the power by 1, so -1/2. Okay, I also need to bring that half out the front, don't I? Alright, so that's half x plus 2 to the -1/2. Now, it's probably going to be easier if we're still working in terms of that square root though. So rewriting this, we get 1 over 2 square root x plus 2. Okay, we're not done there yet though, because we need to write it in terms of dx. So we can write it as dx equals, how should I write this? It's du over 1 over 2 root x plus 2. And of course that's ugly. Du over 1 over 2 root x plus 2. If I'm dividing by a fraction, that means I'm multiplying by the reciprocal. So I can write that as 2 root x plus 2 du. Alright, now that we've got all of that, let's write our u substitution. So I'm going to write in x was 7, u is equal to 3. So substituting 3 in for that. When x is -1, u is 1, so I can put that one in there. And I'm going to write the whole thing out without the u substitution for a second. So 3x over root x plus 2, and then instead of the dx, we have this times 2 root x plus 2 du. Okay, so that root x plus 2 and that root x plus 2 cancel each other out. And I have the integral of between 3 and 1 of 3x times 2, so not 3x, 6x du. Okay, so I have a function in terms of x, but I'm finding the derivative in terms of u. So here's where I can do that u substitution. So turns out I haven't done enough work yet because I need to know what x is equal to. So if u equals root x plus 2, then u squared equals x plus 2, and u squared minus 2 equals x. So now I can sub that u squared minus 2 into my integral. Between 3 and 1, 6 u squared minus 2 with respect to u. Now expanding, that's no big deal, and integrating, that's no big deal. And we're firmly in methods territory now. We're just going to sub 3 in there and sub 1 in there, subtract 1 from the other. Alright, subbed it in, got some numbers. When we do the calculation there, we'll get 28. I think we are done. Evaluate this using the substitution this. Alright, our final answer, 28. Okay, so this is a nice question. They give you the substitution that you need to do, but there is quite a bit of work to do to get to that final answer. Alright, time to look at that last question. Alright, so we're in Western Australia again, 2019 this time. It's worth 6 marks, so give yourself about 9 minutes. And I'm going to solve it in 3, 2, 1. Let's do it. Alright, so it's complex numbers here. We need to show that z minus 2i is a factor of that. So if z minus 2i is a factor, then I should be able to substitute 2i in for z and get an answer of 0. Alright, so there's that just in written form. Alright, let's sub 2i in there. Alright, I've subbed 2i into there. Now, it feels like if I just write like 0 here, it feels too much like cheating, like I'm not giving them enough information that they want. They obviously want me to be able to do this thing, so I need to show off a little bit. Alright, so 2 to the power of 4 is 2, 4, 8, 16. I to the power of 4 is equal to 1, so that's just 16. Alright, 2 to the power of 3 is 8. I to the power of 3 is negative I. So I've got minus 2 times 8 times negative I. Alright, I'm going to leave that like that for now. 14 times 2 to the 2, so that's 4. 14 times 4. And I squared here is, I squared is negative 1, so times negative 1 there. And we have, okay, we can do this all in one shot, 16i plus 40 there. Okay, tidying this up, we have negative 2 times 8 times negative I, so that's positive 16i. We have 14 times 4, which is 56, but we've got a negative 1 here, so negative 56. And we have that negative 16i there, and we have positive 40 there. Alright, looking at the real components, we have 16 minus 56 plus 40, that's 0. And we have positive 16i minus 16i. I think that's enough, 0. Alright, I think that's worth the 2 marks that I've been asked for here, so we're in business. Alright, so it says hence or otherwise, let's just go with hence. Hence, solve the equation pz equals 0, giving solutions in the form a plus bi. Okay, we need to deal with our conjugate root theorem. Notice all the coefficients here are real numbers. That means the conjugate root theorem is in play. So if z minus 2i is a factor, then z plus 2i is a factor. You can write is a factor there, but okay. So we've got 2, z minus 2i and z plus 2i. So what does that mean for us? It means that the function pz is equal to z minus 2i times z plus 2i multiplied by some other function which we'll call qz. Alright, I'm going to show you two ways to do this, but the next step is always, everything so far has been the same. Alright, z minus 2i, z plus 2i, I can expand that now and get z squared plus 4. At least I hope that's right. Negative 2i times positive 2i is negative 4i squared. I squared is negative 1, so positive 4. Okay, so we have z squared plus 4 times some function qz is equal to pz. And we know that pz is equal to that. Now that of course means that pz divided by z squared plus 4 would be equal to qz. And in order to figure out what this function qz is, I can do polynomial division there. Don't worry if you don't like polynomial division. I'm going to show you a different way to do this without polynomial division. Alright, z to the 4 divided by z squared is z squared. Z squared times z squared is z to the 4. Z squared times 4 is 4z squared. Alright, it's not quite how we want to do it though, because we don't have a z cubed term. So we'll put in a little plus 0z cubed there, and we'll put our plus 4z squared there. Alright, subtracting them, z4 minus z4, we get 0. Minus 2z cubed minus 0, we get negative 2z cubed. And 14z squared minus 4z squared, we get 10z squared. Continuing on here, minus 2z cubed divided by z squared, we'll get minus 2z. Minus 2z times z squared, we'll get minus 2z cubed. Minus 2z times 4, we're going to get, alright, we're not going to get that, so we're going to get a 0 there, and we're going to get negative 2z times 4 is negative 8z. Alright, doing our subtraction again, minus 2z minus minus 2z is 0. 10z squared is what we'll get here. Minus 8z minus minus 8z, so minus 8z plus 8z, we'll get a 0 there. And let's drag that 40 down. Okay, and finally 10z squared divided by 10z squared is 10. And I think everything should finish up here. 10 times z squared is 10z squared. 10 times 4 is 40. We've got a 0 term here for the z. Subtract them each other, we get a remainder of 0. So, therefore, pz is equal to z squared plus 4, which is equal to z minus 2i times z plus 2i, minus 2i, times z plus 2i, times z squared minus 2z plus 10. Okay, it feels like we can probably factorize z squared minus 2z plus 10. So we'll use completing the square for this bit here. So we'll go z squared minus 2z, halve this and square it, we get plus 1. We've got to pair it up with a minus 1 and a plus 10 there. Okay, so write this out again. Z squared minus 2z plus 1, we'll get z minus 1 squared. Got to be careful with my brackets here. And that's this part of it here. And then I get minus 1 plus 10, so I get a plus 9 there. Okay, now what was I supposed to be doing again? Giving solutions. Alright, so from here I can definitely solve this, right? Because this is supposed to be equal to 0. And I've got a null factor law going on, which says that z minus 2i is equal to 0. Z plus 2i is equal to 0, or z minus 1 squared plus 9 is equal to 0. Alright, so these are straightforward. Z equals 2i, z equals negative 2i, and this one, pretty straightforward as well. Z minus 1 squared equals negative 9, z minus 1, the square root of negative 9, plus or minus, obviously. Now the square root of negative 9 is 3i, so plus or minus 3i, z minus 1. So z is equal to 1 plus or minus 3i. I'm finished. I have 4 solutions. Z equals 2i, z equals negative 2i, z equals 1 plus or minus 3i. I have 4 solutions. All right. What if I wanted to do this a different way? What if I did not like this stuff? If you don't like polynomial division here, we can pick up the action from here. And we can say that PZ, which we know what PZ is. Okay, there's our PZ there. Now, it's a polynomial of degree 4, right? Now, that's going to be equal to this thing here, Z squared plus 4, times some function. Now, if we've got a quadratic function, degree 2, multiplied by some other function making a degree 4, then the thing it's multiplied by would need to be a quadratic as well. That's the only way we're going to get to a z to the power of 4. So we can replace it with az squared plus bz plus c, where a, b, and c are unknowns to us. How does that help us? Well, we can expand these brackets now. So here you can see I've expanded the brackets. I've got 6 terms. Now I can group some like terms here. Az to the 4 plus... I've only got one z cubed term, bz squared. I have cz squared plus 4az squared. So that's going to be 4a plus c z squared. I have 4bz and I have 4c. How is that useful to me? Well, now I can equate terms between the left-hand side and the right-hand side. So you can see my constant term 40 and my constant term 4c. So 40 equals 4c, therefore c equals 10. Okay, we have negative 8z equals 4bz. So therefore, what do we have? Negative 8 equals 4b, and b equals negative 2. And you can see I don't really have to use this term and this term here. I guess I can use this term as a check, right? Because that says bz cubed, negative 2, negative 2. Okay, that's checking out. But we've got this a value here. So we can say that z to the 4 equals az to the 4. Therefore, a equals 1. And we end up in the same spot because now we can say, therefore, PZ, which is this thing here, is equal to z squared plus 4, which when we expand it is z minus 2i, z plus 2i, times this az squared plus bz plus c. But az squared, a was just 1, b we knew was negative 2, and c we know is 10. Okay, and you can see I've wound up, by doing that process, I've wound up in the same spot there, right? So if you don't like polynomial division, you can do this thing here. But in the end, you are going to end up in this spot. Now, I've done a bunch of factorizing here. You can kind of do something a little bit different because you can solve that one straight away. You can solve that one straight away. And you can solve that even by like using the quadratic formula or something. But in any case, that's how I've chosen to solve that question. If you're still watching this video at this time and you can like comment, I'd be very interested to know whether you like using option 1 over here or the alternative here, just for interest's sake. All right, that's it. We've done 4 questions. So we've done 2 tech-free ones. We've done 2 tech-free short responses. We've got a few more to go there, but the next ones will be tech active. I'll see you on that video. Happy studying.